Okay, so we have gotten to enlargement era in transformation. Enlargement, we dealt with enlargement. We dealt with enlargement with respect to scale factor and the center of enlargement and the description and the positive scale, the negative scale factor, and the whole number scale factor and the fraction scale factor, and what each of those things do, right? So, and I also told you that there are a number of things that you need to study on the must-know sheet. All right. They're all very important. I mean, I can say almost all of it just out of my head without looking at anything. And that's how I want you to know it. For example, you need to know that if you're describing a translation, you have to give the components of the translation. How many units left, how many units left or right, and how many units up or down. Maybe the right, the translation is positive, going to the translation is negative. Going up, again, that's a positive. Going down, that's a negative. But that's for translation. And translation is given by a matrix AB. All right. So this one is for the left and the right. All right. And this one is for the up or the down. That's translation. All right. Then we spoke about reflection. We say if you're describing a reflection, you must state the mirror line. You must state the mirror line if you're describing a reflection. I would say that there are a number of
Sir, your mic is muted.
All right. We said that there are a number of reflection matrices that you must know. So for example, you must know the y-axis reflection matrix. Y-axis reflection matrix, the one, the first negative one in it, negative 1, 0, 0, 1. You need to know that matrix. If you can remember that one, then it's easy to remember the x-axis for reflection matrix. X-axis reflection matrix is 1, negative 1 is down here now. 0, 0. And we'll put these two together to get the 180 degrees rotation matrix. 180 degrees rotation. They're all on the must-know sheet that I gave you. That's the two negatives in it. And this is also equivalent reflection to the origin reflection. Origin reflection. So all the important things you need to know. This is a y-axis reflection. And this is the x-axis reflection. It's all in your notes. All right. Those are your reflection matrices. Then we have the y equals x reflection. Y equals x. Y equals x reflection matrix. Reflection in line, y equals x. So it's easy to remember. It looks like the identity matrix. The identity matrix is this one. 1, 0, 0, 1. Looks like that, but it is not that. The ones are on the other diagonal here. 0, 0. That is the y equals x reflection matrix. You can remember that one, but the y equals minus x. Y equals minus x reflection matrix. If you want to do transformation good, learn these things and know these things as I'm doing here. When I see a transformation question, I can do it right off the bat. And I want you to be able to do it just that. I'm telling you what you need to do in order to be able to do it just like me. All right? Negative 1, 0. All right? That is the key to doing transformation questions, knowing these things. Knowing these things. All right? Those are your reflection matrices. Then we'll come to rotation matrices. The rotation matrices. And it's rotation about the origin. Remember, all the rotation matrices are about the origin. About the origin. The center of rotation for these matrices is the origin. Right? We have the anti-clockwise 90 rotation matrix. That's how I remember it. I put the arrow at the top. The negative one is up there where the arrowhead is, right there. And the one is down here, 0, 0. That's the anti-clockwise 90 rotation about the origin. And the other one, therefore, is the clockwise. The negative is down here instead for the clockwise. Easy to remember. The negative one is down here instead. 1, 0, 0. That's a clockwise 90-degree rotation matrix about the origin. I already said the 180-degree rotation matrix is this. That's the y-axis reflection in and the x-axis reflection in. I can't tell you why both of them give it that one. Look, remember we also said that two reflections were intersecting line equivalent to a rotation. So if I do a reflection over the y-axis and then do a reflection over the x-axis, these are 90 degrees apart. So if I reflect a point over the y-axis, reflect it over the x-axis down to here, right? Then it is the same as doing a 180 rotation about the origin. See, it's as if I did a rotation, 180 degrees rotation about the origin to go from this starting point to this ending point. That is why I know that the y-axis reflection, which is negative 1, 0, 0, 1, and the x-axis reflection, which is 0, which is 1, 0, 0, negative 1, both of them combine to 180-degree rotation, negative 1, 0, 0, 1. It's easy to remember things because two reflections over intersecting lines. These two lines intersect at the origin. So the rotation is at the origin, right? The rotation centers origin, and the angle of the rotation is twice the angle between the two lines. The angle between the y-axis and the x-axis is 90 degrees. So the rotation angle is 180 degrees. You know those things, the question easy, easy, right? And so it's easy to appreciate that this is the 180-degree rotation matrix. Everything together nicely, right? What else did I tell you to know now about enlargement? Enlargement. So enlargement go. A length and an image is equal to k times a length and the object. Where k is a scale factor. K is a scale factor. The length and the image is k times the length and the object. So basically multiply the length and the image by k. Also multiply the distance from the origin or from the center of the rotation. So for example, if this O is the center of the rotation, then OA becomes k, no, OA prime, the image is k times OA. This is our image distance from the origin. This is our distance from the origin, k times the object. Right? We spoke about that. We said the enlargement matrix about the origin. Enlargement matrix about the origin is K0, 0, where K is the scale factor. How does that work? If you have a point XY and you take it under an enlargement of scale factor K about the origin, then it's go to the point KX, KY. You simply multiply these values by the K value. So the scale factor is 2, then you multiply these values by 2. The scale factor is a half, you multiply these values by a half to get that one. Easy. If you remember those things, these questions are easy. Remember, this is for the matrix about the origin. If the center of the rotation is not the origin, you cannot use this matrix. You cannot use it. All right? You cannot use it if that is not the center. If the center of the origin, that matrix is when the center of the enlargement is the origin. What else did we see? We said two reflections over parallel lines. If you have two parallel mirror lines, like mirror line 1 and mirror line 2, right? And I have a triangle, for example, here, and I reflect it, it's going to go there. And then I reflect this one over here, now it's going to come back here. Like that. Two reflections is equivalent to one translation. I'm saying to go from this first triangle straight across to this triangle is a translation. A translation will take me from this triangle to this triangle. So two reflections over parallel lines is equivalent to a translation. If the distance between the parallel lines is d, then the translation distance is twice that, 2d. And the direction of the translation is perpendicular to the mirror lines. Know those and the question is easy. Everything that I've told you comes straight out of my head, you know. Everything that I've told you comes straight out of my head. Let's talk about enlargement again up here. Let's talk about enlargement again. If the scale factor equals something like a third, what's going to happen? The image will be smaller image. 1/3 the size, smaller image. Image is going to be smaller than the object. I reduce the size to 1/3.
Wait, sir, excuse me. Sir,
Yes?
you said that 2 reflections is equal to 1 translation. So if on the
Yes.
end, like I get a question like that.
2 parallel. It has to be in parallel mirror lines. Only the mirror lines are parallel. I'm talking about parallel mirror lines. Pay attention to the details. Talking about when the lines are parallel, 2 parallel mirror lines, equivalent to 1 translation. So if you do get in a graph paper and you have a line, 2 lines, like one line is x, so one line is x equals 1, and the other line is x equals 6. Those 2 lines, and you don't want to do 2 reflections. Then clearly the distance between these 2 lines is 5 units. 5 units. Right? Is the distance between those 2 lines. And if they ask you, it's about a triangle, suppose the same triangle up here that we did, and you do the triangle, and you reflect it over here, and this is triangle A, and you get the one in here which was D, and then the one over here is C. The question will ask you, what single transformation will take you from A to C? That's what it will ask you. Single transformation will take you from A to C. It's going to be a translation 10 units to the right, because the distance between the 2 mirror lines is 5. So it will be 10 units to the right. This is basically a summary of an actual question that CSEC set already. Right? When you know those things, you don't have to get things, you know for sure. If you just say it's going to be a translation, you're not going to get all the marks. You have to know that's a translation, twice the distance between the lines. You know those things to get all the marks. All right? So, but back to this though. If the scale factor is 1/3, the image is going to be smaller. The image is going to be 1/3 in size, smaller, 1/3 of the object, right? 1/3. The distance from the center of the enlargement is also going to be 1/3. What happened? The object and the image will point in the same direction. They will point in the same direction. And both of them will be on the same side of the center. Why is that? Because the scale factor is positive. Positive scale factor does that. The scale factor equals a value like 4. What's going to happen? We're going to have a larger image. It's going to be larger. It's going to be 4 times larger image. The image is going to become larger by 4. It's also going to go 4 times the distance from the center of the enlargement. Right? And then they're going to have the same direction. They're going to be pointing in the same direction. The image and the object, again, will be pointing in the same direction. Right? Same direction. Image and the object will point in the same direction. Both of them will be on the same side of the center. Let's use some negative scale factor down here now. If the scale factor is something like -1/4, let's say -1/4, -1/4, then it's going to be smaller again, smaller image. Again, smaller image. Why? Because of the 1/3. 1/4, I mean. But they're going to point in opposite direction because of the negative. So the image and the object will be inverted. Inverted. That's a key word. Image will be inverted and pointing in opposite direction. Pointing in opposite direction. Pointing opposite direction. Opposite direction. All right? This is just a revision, a quick revision I'm giving you before I move on to today's class. I'm showing you that you can know these things just out of your head. Everything, I'm not looking at anything talking to you right now. I'm not looking at anything at all, just the screen. Everything I'm looking at the screen, you are seeing as well. Right? If scale of value, like for example, 5, you're going to have a larger image. The image is going to be larger than the object because you're multiplying it by 5. You're also multiplying the distance from the center of the enlargement by 5. So the image is going to go 5 times the distance away. right? Using -5. Let's use -5 though. Negative, because we use a positive already. But this time though, the negative is going to invert it again, opposite side of the center. So you're going to point in opposite direction here, but also going to be on the opposite side of the center. Same thing down here. The negative down here again is going to be inverted. Inverted. It's going to be inverted on the opposite side again, opposite direction, opposite. That's what negative do. Opposite direction, opposite direction. I explain all of it, but I'm summarizing now. Opposite direction, and also they be on the opposite side of the center. So the image and the object will be pointing in opposite direction. So when you're doing an exam question, you get a diagram and look at the diagram. You don't do any work yet, you look at it. And one diagram on the image and the object, the A pointing up. And the image, the A pointing down. But you see that the two of them have two different sizes. So you know it's an enlargement, because one bigger than one. Once one bigger than one, you know it's an enlargement transformation you have. That's if you're doing a transformation question. Right? And you say one bigger than one. So you know it's a transformation you're dealing with. You look now at the points pointing. So on the object, the point A pointing up and point A pointing down. Right away, you know the scale factor negative. No, guess how I spell scale factor negative. And then usually you can look at the sides and see that one side is twice as large as the next side. So you know that the scale factor is a 2. The value is a 2, but it's negative because it's pointing opposite. So you know the scale factor is -2. And the question after they describe it, you also need to find the center. How you find the center? Join the corresponding points. You need 2 of them. So you join, like for example, A to A prime and B to B prime. And where those 2 lines meet, that is the center of the enlargement. And if it's a negative scale factor, the center is between them. Between them. And I might ask you a question, why is the scale factor negative? The scale factor is negative because the image is pointing in the opposite direction. I can say the image is inverted and pointing in the opposite direction. And they are on opposite sides of the enlargement. Give them stuff like that. That's what they're looking for. They give you your marks quick. But you have to know the things. You have to know the things. All right. So this is just like a quick thing. I'm certain that there are other stuff, but I'm telling you the reason I can fly through any enlargement question, and you will be able to fly through them as well, is if you know those things on the must-know sheet. Know it like that, like how I know it, and don't have to look at anything. Just kind of write it down out of my head. So therefore, as soon as I see a question, my brain just work like a calculator. Okay, boom, 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 boom. This is the information that I need to use. Right? You must know information in your brain. Just tell you what is that mean. Everything. You can see right through it. You can see exactly what does that mean. If they talk about a reflection and another reflection, you know, so the two of them give you a rotation. They talk about one transformation and then another transformation. You know what the result is going to be. Without calculating, you know what the answer is without even doing any calculation. For example, that you have a reflection over the like that, and then you have a reflection over the line y equals x. So you reflect this first, and you reflect over this one. And they ask you, how you go from this one to this one? What's in your transformation? That's a rotation. That's a rotation here. That will become rotation, right? You're gonna rotate about here, about the center of the enlargement, right? And since the angle between these 2 lines is 45 degrees, since the angle between the 2 mirror lines here in order is 45 degrees, then it means that the rotation angle is 90 degrees, twice as much, 90 degrees, right? And that's to be at 90 degrees clockwise. So if they ask for the matrix to go from this to this, you can tell them as well. The -1 is down here, 1 up here, 0. That's the matrix. You don't have to work, you don't have to work it out. You know it, you just write it down and you're gone. Get your marks. Right? I know that if them ask for the matrix, this is it. I'm going to know how to calculate it from this one and this one, which is something we're going to do today. How do you calculate this single matrix from the y-axis matrix and the x-axis matrix? And the y-axis matrix will be -1, 0, 0, 1. And the x and y equals x will be 0, 1, 1, 0. To get this one, you multiply the 1 here times the 1 there. multiply them. That's how it works. You apply this transformation, the second transformation to the first one. Something we're gonna do today. And I already know that this is gonna be the answer. So we work it out, I'm actually get this as good. I know my answer before I even do it. That's the point. That's where we want to get to with this topic. Remember, this is the one topic that you can have the same questions on the same paper, you know. 2 transformation questions can come on one exam, you know. You can get one in section 1 that is dealing with the diagrams, like you know, constructing the transformation with the diagram. And then you can get one in section 2 that is now you're gonna be using the matrix. You can get a transformation question in section 2 where you're using the matrices, 2 different kinds of transformation question. One way you have to draw the diagram, like do the reflection on a graph, or do the rotation on a graph, or something, do the enlargement on a graph or something. So the matrices not come into play with that one. And then one in section 2 now is the one where you calculate the various things with the matrices. Right? So you can get 2 transformation questions on one exam paper. You want to don't get them right. Right? Transformations are a big part of the exam. We need to crush it. Right? And vectors too, which is our next topic. We need to crush those topics. Right? But why again? Because it's the same set of things the set time. All the questions are around the must know item that I gave you. The must know items that I gave you. All the transformation questions are centered around those things all the time. Almost any transformation question you get, you can look on must know sheet and see something on that must know sheet relating to it. You can point them out to you when the time. All right, so just take this little time just to emphasize, guys, the importance of studying. Not that just understand, meaning like know anything in maths, you must SWAT. Those things. The more things you know, easier the questions will be. You don't want to go in the exam and have to be thinking out and trying to remember stuff. Have them in your brain, have them on your fingertips. Know them to that level. That means once you see the question, you know the answer already. That is the level that you want to. So if the questions are always centered around these set of things, just know them and done. Know these set of things and done. Take the time and learn them. The exam is all the way in me. You have all the time to learn them. Start learning from now. That means when we get back to now, I will start revising them in your brain already. Right? Right? I will practice the question now. You'll see how you already apply. But I needed to start learning them. Know them. Just as though you know somebody's phone number. Just know it. Just as though you know your email address. Just know it. Just as though you know your mother name. Just as though you know things like that. Just know it like that. Just know it. Just as though me can just see you on the page. Just know them like that. That is how I wanted to know them. Not no gimmicks thing. So I decided, because some persons over the break, you know, since Monday, you know, and I get the sense that they don't really understand when I tell them, so they must know it what I really mean. You know what I mean? Just understand it and look it over, you know. I mean, make it stuck in your brain. That's what I mean. Just as how you get somebody telephone number, you decide say you want to know the telephone number, you don't forget it. That is how we must know it. Learn the matrices that way. Learn the rules that way. Learn everything I'm telling you, transformation. That is all I want to know it. Because if you know it, that is a question and example. You want to breeze through quick. And they can give more time to the other questions that they don't set the same way all the time. Transformation questions, they basically set them all the same way, relatively the same way all the time. And all the questions are sent that must know sheet that I gave you. It's very, very important. Don't do the thing, man. Right? You have to be intense with this subject. Intense. You can't just scratch the surface. Don't scratch the surface. You have to go deep in it. Intense level of preparation we're talking about. Not about just scratch like what other people do. I'm barely I learn the thing, I know the thing. No, we're not talking about that. We're talking about some in-depth knowledge. Can get up in the middle of the night and just write down the things I want. That's the level of knowing that I'm talking about. I hope people understand now. And there are more must know items that you'll learn as we go. And when know them. That is what I talk about. If you really want to do maths easy and make maths and just fly through maths question, you have to know things. All right? It's as simple as that. Not just understand them and not be struggling to remember. I'm not about struggle to remember things. Right? When you want to use something, must be at your fingertips. You can just recall it right away. This is the level of knowing I'm talking about. Like you can just say your name. I can just say your address. That's the level of knowing that I'm talking about. I hope everybody understand that now. So going forward, when I tell you that something is a must know, that's what I mean. That is what I mean. I don't mean struggle to recall it. I struggle to remember it. I know it like that at the back of your hand. All right. Okay, guys, let's get to this thing now. All right, so we are moving forward with the enlargement, right? So we have enlargement to do, and then we have some compound transformation and glide reflection and these things, right? We're going to use some, we're going to be applying some for general knowledge. All right, so when we spoke about enlargement, we mainly focused on distance, right? We mainly focused on distance. What we said, generally speaking, in enlargement, if you have a triangle, for example, and the triangle undergoes an enlargement of scale, so the scale factor is 2, then we know that basically the sides are doubled, right? We know that the sides are doubled. This side is AB, and this side is A prime, B prime. Then we know that A B prime will be equal to 2 times AB. 2 times AB. In S, A prime, B prime is the scale factor times AB. Now note now that the A prime, B prime, we can refer to it as an image length. I'm going to put L, I meaning image. And the K times and the AB is the length of the object. This is the object and this is the image, you know. The image is always the one with the prime. The image is the one with the prime. So this now is K times and object length. Object length. So I'm going to put O right there. So we've been using this, you know, without really calling it this. And the reason I'm taking time to go through this slowly is because CSEC always asks questions in enlargement about area. And for some reason, people not getting it, right? Because they want to they want to just focus. They want to just focus on this one, right? They want to remember this one, and they want to focus on that. I always ask about area. So area have a different kind of relation, right? So that's the relationship between length and distance under an enlargement. So I can just write the one for area over here so now and show you, you know. The relationship for area now becomes a square relationship. So the area of image becomes now K squared times the area of object. That's when it comes to area. So this one is for distance or length, and this one is for area. This one is for area. All right. Oh Lord, the class to start to bang. All right. Let's bear me with the banging a little bit. Some of the banging something outside. Hopefully there's some stuff. All right. So that is distance and that is area. But why is this a formula? Why is it we end up with this as a relationship for area? And what on the left side on the slide now is just proof of it. And you will not enlargement question and this don't come into play. So you have to know this as well. And it's on the must know sheet. That's relationship when it comes to area. Area of an image is always the scale factor squared. Note the scale factor squared. Scale factor squared times the area of the object. When it comes to length, the length of an image is just the scale factor times the length of the object, which we realize that already. But for area is a relationship square. So what I have on the left side now is just a little proof of it. Just a little proof as to why it is that, why it is so. All right, so let's look at these this square. So we have this square and we have that square. And what happens is that we're going through an enlargement of scale factor K. So the sides now, this side is multiplied by K and becomes that, and this side is also multiplied by K and becomes that. And so we get a a larger square over here, which is K times the first one in terms of the length. If you were to look at the area of each of them now, if we were to look at the area of each of them, the area of the object would be x squared, x times x, right? X times x would be area of the object, x times x, because it's a square now, so it will be x squared. And the O here is something object, right? So area of object. Trying to use the same notation that I use over here, right? So, and if you looked at the area of the image now, that is it. Because how we get the area of the image to be that? Because you don't know, it will be kx, that is this kx up here, times kx, which is this kx down here. So it's this kx times this kx. That's what we have here. So now that gives you k times k is k squared, and x times x is x squared. That's how we get that to be the area of the image. And a simple thing now, if the area of the image is that, and the area of the object is also x squared, that means that I can take this AO and put it right here for the x squared, because they equal the same thing. So you really see that the area of the image is k squared times the area of the object. All right, everybody can see that. If I just make that substitute, that's what we get. And so that's how we end up with that relationship. And as I've said, this is a must-know relationship. That's a must-know relationship. And it's on the must-know sheet. Right? Sometimes a question will ask you, for example, what is the area of an object? What is the area of an image? So the question asks you, what is the value of, I might get something like area of triangle A prime, B prime, C prime divided by the area of triangle ABC. Right? I must realize that this really is area of image. That's right, area I over, and this one is really area of object. That's what that is really, and that is simply k squared. Now, some people would work out the area of the triangle, that's and work out the area of this, in order to get this, when it is simply all you have to do is just square the scale factor, and you're done. Square the scale factor right there, and you're good. That's all you have to do. Right? And sometimes they give you some shapes that you can't even find the area. You can't even find the area. You know what the scale factor is, You can't find the area, and you can't find the area. So you have to know this. You have to know that. And we can see it right here, because if I divide by the A square, the AO, I get the A of image over A of object equal the scale factor squared. So it's something that I ask pretty often. The answer is A squared. And we'll start with the questions you want to see. Area of image, area of object is equal to K squared. Right? And it stems from this formula. It's just a transposing of that right here. All right, that's the relationship for area, guys. So let's move on. Area of image is K squared times the area of the object. So that is on the must-know sheet. You have to learn it. This one is not on the must-know sheet, this one. So if you like, you can write it on, even though it's understood and it's already known. Right? But you can write it on. But this one on the must-know sheet. And you have to learn it as well. All right, so now you understand. Now we're going to do questions and see. All right, so let's move on now. So we're going to look at now the compound transformation. We're going to start with a simple one, which is a glide reflection. And a special kind of transformation. You have to pay attention to the details of it. It comprises of a reflection and translation. It's called a glide. So it has its name glide reflection. So not glide reflection is involved. You see, the glide part really is a translation. That's what I mean. The glide part is a translation. So it's a translation and a reflection. Only thing though, guys, is that it's a glide translation here. it has to be parallel to the mirror line. That's key. The translation direction has to be parallel to the mirror line for it to be a glide reflection, and that is the key in this one. Not just any translation and any reflection. A combination of a translation and a reflection where the translation direction is parallel to the mirror line in the same direction as the mirror line. Let's look at it. So this transformation is produced by a combination of a reflection in a mirror line and two, a translation that is parallel to the mirror line. A glide reflection, and plenty of people miss it all the time in exam. I don't want my students to miss it. It's also on the most no sheet there. All right, a glide reflection. Let's look at this example of a glide reflection on this diagram. So I have that triangle ABC, and I have that image triangle A prime, B, C prime, and I have that red line. That red line is a horizontal line passing through 6, so it's a line y equals 6. I'm telling you from ABC and B prime, C prime, really is a glide reflection, right? Look at how it would work. First, you have the glide. Everybody can see the glide, the translation there? Some of you can see it. This glide to here first. But I can see that? So yes, glide to here. Good. I see it is in this parallel. It is parallel to the mirror line. Right? It is parallel to the mirror. And then after that, now it is reflected. After that, it is reflected. And that's how we get to this one. That's how we get to that one. So about our translation that is parallel to the red line, and then we have a reflection over the red line. Everybody see that? Everybody can see that? That's how we go from the object to the image. I'm going to leave the final object, the image unshaded. Right? We could also do the reflection first. Right? That's the beauty about the glide reflection. You can do the reflection first. See there? We have done the reflection first. Look at it. So instead of doing the glide first, we have done the reflection first. Right? That's the thing with it. So this time now we're doing the reflection first to get this. After we finish the reflection, bam, we do the glide. And the glide is still parallel to the mirror line. So you see, it's still a translation parallel to a mirror line and reflection over the mirror line in any order. It doesn't matter which one you do first. The result is going to be the same. Right? The result is going to be the same in that you start here and you end up with this one. It's a glide reflection. A glide reflection. And that's it. I don't need to do anymore. And all thing is that they might ask you to describe it. So you're going to describe it, you have to describe each part. You have to describe the translation part and the reflection part. But it don't matter which one first. The translation is how many units to the right. Let's look at it. How many units to the right? So use a B point, for example. Right? Use a B point, for example. So the B point from here all the way over to there. That's translation distance now. That's 1, 2, 3, 4, 5, 6 units to the right, from B to B prime across horizontally, and then it is reflected. So the translation is 7 units to the right, and then the reflection over the line y equals 6. So how would we describe that one now? Let's look at it. One of the describe it. You know, triangle ABC undergoes a glide reflection. So they ask me to describe this transformation. Tell them it's a glide reflection, and then components of the glide reflection. That tell them the translation part and the reflection part in order. It doesn't matter which one they state first. Right? So I'm giving them the reflection line first. It's a reflection line, y equals, that's a red horizontal line there on the diagram, on the graph. And a translation 70. Remember, 70 means 7 units to the right alone, you know. Translation was 7 units to the right. That's how you describe that glide reflection. And that's it. That's glide reflection in a nutshell. The next glide reflection is going to be in one of those class activities we're going to do. All right? That's how glide reflection works. If it's a vertical mirror line, you could maybe like this. Let's do one over here and show you. Fast and furious. So, a triangle is, which is the actual question I'm showing you now. A mirror line here, a mirror line here, maybe that is the y-axis or some mirror line, right? And image. I'm making a lot of noise, boy. And then you have your image up here, and to be a reflection. So it will basically face this way. Right? That's a glide reflection. Why is the glide reflection? A translation to come up here so first. But you can see that? That's a translation to come up there so first. Let's put the translation in purple. Translation up there. It's kind of too far, put it closer. And then I did a reflection to get this one. See? It's a glide reflection. So it's a glide parallel to the mirror line and then a reflection over the mirror line. And that's it. From this to this is a glide reflection. Right? How many units upwards? This might be, suppose this are 5, suppose this are 5 units upwards. Then to be just 5 units upwards, so it'll be t equals 0, 5. I don't go horizontal, no, 0, 5. And is the x-axis, y-axis. So this is the y-axis. So this is the y-axis. 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 So this is the y-axis. Then my glide reflection will be a translation, which is this, and a reflection over the y-axis. Right? My glide reflection. So I can say object, image. So I say O is mapped onto I by a glide reflection. Glide reflection. Glide reflection. Translation. T equals 0, 5. That means 5 units upwards, and a reflection in the y-axis. That will be my description. I give the translation part and the reflection part. Just always make sure that the translation parallel to the mirror line. That's it can be a glide reflection. All right, I could have given the reflection first if I wanted. As you know, if I reflect over here and then do the translation up here, the result is the same. That's my glide reflection right there. Done. All right, so let's move on. So we're going to look at now is compound transformation. Right, so on the must know sheet as well. Almost every exam question you do, you're going to get a compound transformation. Compound transformation, I can tell you right now, is similar to composite function. Just as though in a composite function, remember the composite function f of g. What did this mean? This meant g followed by f. That's what it meant. Remember? This one first, followed by that one. Remember, if we had, for example, f of g of 2, we have to do the g of 2 first. It would be equal to f of g of 2. So I mean the g of 2 first, and for the g of 5, then it becomes f of 5. It becomes f of 5. If the g of 2 works out to be 5. If this works out to be 5. So the compound transformation is a similar thing. You're gonna see like two compound transformation like MR. R might be a reflection, and R is a rotation. This would mean this would be the same thing. R, this one followed by this one. MR means R followed by M. And just as though you can in the just as though in the composite function, you can actually form one function by putting the G into the F. You can do them separately, but you can also form a composite function by putting the G to the F. You can also form a compound transformation by multiplying these two things, the M times R. We still have to know, so the M times R means R. It means R followed by M. You have to remember that MR means R followed by M. And if these are two by two transformation matrices, you can multiply them. You are free to multiply them and get a single matrix. But let's just go into it though. Let's just go into it. I'm just sort of showing you the relationship. All right, relationship that it has with regular functions that we learned already. Right? So if you understand already and a composite function already, then you can understand compound transformation. It's very similar. All right, let's look at it. So this is a rule. Starting with the rule. If F and L are two by two transformation matrices, and the key word is that it has to be two by two transformation matrices. We're talking like, for example, two by two transformation matrices. Remember that the translation matrix is, so it means that translation is this, like this. So this rule is up here now. We can form a single matrix, right? It does not involve translation. Only the two matrices transformation. So we're talking about the reflections, rotations, and the enlargement. So this same thing really relates to the reflection, the rotation, and the enlargement, because those are your two by two matrices. So let me start by saying that first. This is in relation to two by two matrices. All right. You can still have compound transformation with the translation, but you can't form a single matrix. So we get to that when the time comes. All right. So let's go again. If you have two by two by two transformation matrices, then the single matrix, if you want a single matrix, which is equivalent to those two transformation matrices, where you have the first one followed by the last one. That's what the F stands for, first and last. F transformation F followed by L. Transformation F followed by L is obtained by the multiple L times F. L times F, not F times L. You don't multiply the first one by this last one. You multiply the last one by the first one. What they say is that you apply the last one to the first. You apply the last one. Mute your mic, please. Mute your mic. Mute your mic. You apply the last one to the first one. That's where you form a compound transformation. You apply the last one to the first one. So you multiply the last one by the first one. Just as when we're doing the composite function f of g, right? You put the second one in front of the first one. So this may be followed by f. The same thing here. The same thing here. Right? You apply the last one to the first one. So f followed by L. See it here? F followed by L. F followed by L is LF. Second one times the first one followed by L is LF. And we're going to see the calculations work it out, right? Note careful the details. Note the details. It is not FL, not F. Don't multiply the first one by the second one to get the single matrix. Don't multiply the second one by the first one. FL, this FL here, it means L followed by F. I'm talking about L followed by L. I'm talking about F followed by L. We're talking about F first, L second. F first, L second is L times F. L times F. The last one multiplied by the first one. Last one multiplied by the first one. Pay attention to the details. All right, let's continue. That is last multiplied by first. That's it. Therefore, if M and R represent two transformation matrices and P is a point, so M is like a reflection and R is like a rotation. And P is like a point. P is like a point, right? And we're going to do the transformation. And these are some of the functions you have to get familiar with and used to. MR, if you say MR, it's R followed by M. It means R followed by M. Means do R first and then do M. See there? Apply R first and then apply M. See there? Similar to the functions. Apply R first and then apply M. MR means R followed by M. When you multiply them, you're going to get a single matrix, you know. Still, the single matrix to do the transformation in one step. If you're doing it step by step, you have R first and then do M second. MR means R followed by M. Continue. Another way they could explain is something like that. R on P, similar to the f of G of X. MR on P means apply R to P first. Apply the R to P first, and then apply M to the result that you get after you apply the R to P. Because MR means R first, M second, R followed by M. Pay attention to the details. All right, see there? MR means M followed by R. Right? Means R followed by M, sorry. MR means R followed by M. So see it here? Apply the R first. And see, I'm showing you it is similar to doing that. F of G of 2. We have to do the G of 2 first and then apply the F to the result. MR and P means do the R and P first. Apply the R to the P first. Apply the R to the P first. Pay attention, guys. This is it going step by step now. So if you have the point P, carry to a transformation, MR and P. You have to apply the R first. That's what you see here in the first step. Apply the R first, and that takes you to P prime here. And after we get to P prime, then we apply the M now to the P prime to get P double prime. Mute your mics, please. Mute your mic. All right? That's doing it in 2 steps. You go from P prime using the R. They go P prime to P prime to P double prime using the M. You do the R first. MR means do the R first. All right? That's doing it in 2 steps. But if you want to do it in one single step, single matrix, see there? You want to use a single matrix up here. A single matrix you want to use. Instead of using 2 matrices, R and then M, you can use a single matrix, which is a matrix where you get multiply the M times R. So multiply the matrix by the R matrix. When both of them are 2 by 2 matrices, you multiply the M matrix by the R matrix. Those 2 matrices, you're going to get one single matrix. If you apply that one single matrix that you get to the point P, it's going to take you straight from P all the way over to P prime and cut out the steps where you make over there. So that's what this is all about. Similar to we're doing the F of G. Look, remember, if we're doing the F of G on 2, look at it now. It's on the slide here, but if we're doing the F of G on 2, we have 2 options. We can do the F of G 2, and then let's say the G of 2 give me 5. Then we do the F of 5 and get my final answer down here. Otherwise, over here, no, I can form a composite function F of G and apply the full F of G. If I want to do F of G of 2, F of G of 2, I can work out the F of G first, the full F of G function, and then apply it to the 2 and get my final answer down here. Just to apply the composite function to the 2 answer. The transformation is similar. You can do it step by step and do the 2 calculations, or you can do 1 calculation with the composite. In case of transformation, they call it compound. In case of function, they call it composite. In case of transformation, they call it compound. See it, you know? See it, you know? Bam. That's if you want to do it in 2 moves. So you move from P to P prime first with the R, and then move P prime to P double prime with the M. Remember, MR means R followed by M. So you have to do the R first. If you want to do it in one step, you multiply the M and the R. Multiply the M times the R. Single matrix. And we use that single matrix that you get and apply to the P. You do it in one move right there. One move. That's what the compound matrix does. Does the transformation in one move. This getting a single matrix applies only when you have two 2x2 matrices. So if a translation is involved, you cannot do it in one move. You have to do it in two moves. Translation is one of the transformations involved. You have to do it in two moves. The one move thing in transformation can only work when you have two 2x2 matrices. So that means that you're not including the translation. Translation not valid. Translation matrix. Can I use it? Translation, no. The translation. Cannot do it with the translation. You cannot get a single transformation with the translation. If one of them is a translation, it cannot be. You have to do it in the two moves. We're going to see that later on with some questions. Let's continue. So let's look at an example now. Let's look at an example. And this is where the strength and the power of the must know come into play now. All right. I think we actually did this already, but I'll just show you officially now. Right. This is something that we looked at in the last class briefly. So let's say we have these three transformations. We have a reflection over the y-axis, a reflection over the line y equals x, right? And then we have a 90-degree rotation about the origin. I'm showing the relationship between these two and all these two can come together to give you that one. That's what I'm showing you. All right? All those two come together to give you that one, to be equivalent to that single one. All right, let's look at it now. Bam. That's the matrix for the y-axis reflection. -1, 0, 0, 1. One for the y equals x reflection is that one. Calling that mirror line number 2. So we're calling them M1 and M2. So M1 is a reflection over the y-axis. M2 is a reflection over the line y equals x. And then we're going to call the rotation R90. And we're talking about the clockwise rotation. So that's the matrix for the 90-degree clockwise rotation. I'm going to show you that you can multiply these two. Multiply this one by that one, and it will be equal to that single one over there. Because a reflection over the y-axis followed by a reflection over the line y equals x is equivalent to a 90-degree clockwise rotation. And so you have to multiply this matrix in front of this one to get that one over there. All right? Multiply the second transformation by the first one. Let's look at it. Bam. And followed by M2, based on what we just said, is equivalent to M2 times M1. Second one by the first one. M2, M1 followed by M2. A reflection over the y-axis, that's what this one is. That's what this one is. A reflection over the y-axis here, followed by a reflection over the line x, which is that one, is equivalent to the M2 times the M1. Second times the first one. So we'll multiply them. We'll multiply the second transformation matrix by the first one. And to carry out that multiplication, you're actually going to get the 90-degree rotation matrix because that's what they are already equal to. So if you actually multiply them, you're going to get that matrix, which is the clockwise 90-degree rotation matrix. There is a matrix. This one is this one. So you see if I multiply this one in front of this one, it's not equal to this one over here. Right? This one over here. And we said it. It's a reflection over the y-axis followed by a reflection over the line y equals x is equivalent to a rotation. I put on a diagram short and show you as well. That's a 90-degree clockwise rotation. Right? 90-degree clockwise rotation about it. Let's put on the diagram now. It's the diagram here now. So I'm showing now my y-axis. That's my y-axis. That's my line y equals x. Two mirror lines. Both of them meet at the origin. Both of them meet at the origin. The angle between them is 45 degrees. So if I reflect over this and I reflect over that, I'm going to get a 90-degree rotation. And so I'm putting it on the diagram now. Pay attention. Bam. So I have that point P. First, M1, which is reflected over the y-axis. M1 takes me to that point. And then to M2, which is to reflect over the line y equals x. I do that second reflection, bam, I end up at that point. Question is the single transformation that's going to take from P to P double prime, 90-degree clockwise rotation based on what we said, right? That's it. So that is now equivalent to going from P to P prime. I have to use a rotation, bam, bam. See there, a rotation, 90 degrees clockwise, bam. That's it. 90-degree rotation about the origin, and that's it. And that confirms it for us. Confirms it for us. If you want to get the single matrix, you buy the second one by the first one. Also, it confirms that two reflections over intersecting lines is equivalent to a rotation about the point of intersection of the two lines. And also remember that it is twice the angle between the lines. And twice the angle between the lines. Put it down here. And twice angle between lines. So on the must know sheet, the angle here is 90 degrees because the angle between these two mirror lines is 45 degrees. That's the reason, right? The angle between the two mirror lines is 40 degrees, so the rotation angle is 90 degrees. But understand that?
Yes,
But
sir.
understand that?
Yes, sir.
Good, good. You need to understand it, right? Because you can know that the answer is this without him before you do it, because you already know this. You know the two reflection intersecting lines is a rotation already, and the rotation angle is twice the angle between the lines. Angle between these two lines is 45 degrees. Therefore, the rotation angle must be 90 degrees, 90 degrees, and the 90 degree matrix is that. So you know, so multiply that one here by that one there. Multiply the second one by the first one. It's going to be equal to that. That's what I mean when I say the answer before you do it. I putting everything together. That is what I mean when you say know the answer before you do. So you know that when you multiply them, you will get the matrix. Because that is a 90-degree rotation matrix. So if you know, say, you're supposed to get the 90-degree rotation matrix, and you multiply it, you get something different. You know, so something wrong, you know you make a mistake because it's not matching back with this rule. Everything have to be in sync. Everything have to be in sync. What you get logically based on the rules and what you get by the construction. What you get by the construction match what you get by calculation. The construction and the graph must match what you get in the calculation. That's another thing I need to understand. What you get on the construction must line up, must be in, must match what you are getting with the calculation. And that is where the knowledge come into play. Because you know where you're supposed to get by calculation. You also know where you're supposed to get by construction. Because you know those rules. So once you've seen something that matches, no. That's why I say you know when your answer is correct. Because you see that everything is aligned. You get in the matrix where you're supposed to get, right? You multiply the second by the first one. You know the matrix where you're supposed to get. When you multiply them, you actually get it. That's what I'm talking about. All right, that's the power of the must know items and doing a transformation question and knowing the answer that you're supposed to get. And when you get it, you know, say you're right because everything is in. All right. Inverse transformation. I was to talk about it already. Inverse transformation. I'm coming to the last of it. You know, inverse transformation. We basically did all of them. Inverse transformation is common sense. It common sense. With respect to the matrix, if one matrix do a transformation, then naturally the inverse of that matrix will do the inverse transformation. Inverse of a matrix, 1 over the determinant times the adjoint. So that's how we do it in matrices. Same way we do it in transformation. So if a transformation matrix do something and you want to reverse the transformation, they use the inverse. And you calculate the inverse matrix the same way. Right? The only inverse they calculate 1 over determinant times the adjoint is the translation one, which is just the column matrix one. So we know, so if you have a translation t equal, for example, negative, if you have a translation t equals, so a translation t equals T equals 4, 5. I want the inverse of that. The inverse of that, which is basically minus T, inverse of a translation minus T, is minus 4, minus 5. If it's a 2 by 2 matrix transformation, it's a 2 by 2 matrix transformation, and the matrix is A, B, C, D, and that's a transformation matrix, M. Then the inverse transformation is M to the minus 1, or you get it M to the minus 1 over the determinant, which is AC minus BC, times the adjoint. Interchange those two. Leave the other two where they are and change the sign. A, B, C, D. A, B, C, D, D. So D up here, so. Right? And change the sign. And this become negative C. That's it. So these two will be inverse transformations of each other. Same way you calculate the inverse matrix. Right? So there's nothing to it really. And also all the transformation inverse are common sense. The translation, inverse of a translation, basically going opposite direction. Simple. Opposite direction. So it's minus T. Right? So if 4, 5 carry one way, then it's minus 4, minus 5 carry back the other way. That's translation. Reflection. If you reflect over one mirror line, you want to inverse it, you have to reflect back over the same mirror line. Go the opposite way. Common sense. If you reflect for yourself in one mirror, forget the image. And you want to go back the image back to yourself. Reflect back the same image in the same mirror back. Simple. So the inverse of a reflection in a mirror line is a reflection in the same mirror line. The next one, rotation. Inverse of a clockwise rotation is an anti-clockwise rotation. Same angle, same center, just a different opposite direction. So if I rotate, you just rotate in the opposite direction. Same angle, same center. Inverse of a rotation is a rotation in the opposite direction. Same angle, same center. Common sense. What's the inverse of a transformation of an enlargement? You said it already. If the scale factor is 2 in the first one, that's going to be half to the other one to carry it back. Same center. If the enlargement scale factor was 4, there's going to be a quarter to bring it back. If the enlargement scale factor was negative, it's going to be negative half. Negative half. You have to carry it back and you have to invert it back. So the negative one, invert it back. Right? So the inverse of an enlarged scale factor K is an enlargement of scale factor 1 over K. If it was 2, the inverse is scale factor is now 1 over 2. And again, it's the same center. So the transformation inverse of common sense. You never spend no time on that. Just brain tell you what it is. And you know, big high theory, just common sense. Because the inverse transformation, I think, are omega reach back. All will the object, all the image go back to the object. That's what they basically thinking. And it's common sense. All right? So there's nothing to it. But this is gonna show you about the matrices now. See? Inverse transformation matrix X is X minus 1. So a while ago I used M and M to the minus 1 here, using X and X to the minus 1. Generally speaking, X is used for transformation. And it will return the image to its original position. All right, so if X take it from the object to the image, then X to the minus 1 take it back from the image to the object. And you can calculate the inverse the same way that we do it in matrices. So if a transformation matrix M maps P onto P prime, inverse matrix M to the minus 1 will map the P prime back to the P. So you apply the M to P to get P prime, you apply the M to the minus 1 to P prime to get P. Right? Let me show you what I'm saying. You apply this matrix to this to get this, to get that. You apply the inverse matrix back to the image point to get back the object point. Or you apply the matrix, you multiply the M times the P to get the P prime. Or you multiply the M to minus 1 times the P prime now to get back the P. That's a calculation, you know, simple. You apply the matrix to the point, so you multiply the matrix to the point. We're talking about the 2 by 2 matrices. The only transformation that you add to the point, translation, is the only one that you're adding to the point. So if you have P, you add it to P, you get P prime. If you want to go back to P, you have to subtract back the T now. Subtract it back. All right? So it's common sense, guys. Trust me, it's not complicated. See there? If P take care of to P prime using M, that is the calculation. M times XY equals prime Y prime. So I'm using like these, like our coordinates now, all the points, right? See there? P prime is gonna go back to P using M to the minus 1. See there? M to the minus 1 times the take it back to the object. Right? It's not complicated, believe me. All right, I really want us to do a couple questions today, you know, or even one question. All right, invariant. We spoke invariant. We've been talking about invariant earlier today. We said that invariant is the point that does not change under a transformation, and some of them are common sense, right? Invariant points. So, for example, if you have a mirror, that's the most common example, and there's a point on a mirror line. Points on the mirror line are invariant. In other words, when you reflect a point on a mirror line, it's going to stay where it is because the image distance, the object distance is 0, so the image distance remains 0. Those are called invariant points. When you have a rotation, if I have a rotation, for example, if I have a triangle like this, and I do a rotation about this point clockwise down here, right? Then it's going to go down here. It's gonna come down there. If I rotate it clockwise 90 degrees down there, so right? This point, if that is my rotation point, that's an invariant point, a point that doesn't move. Everywhere else move but that point. Invariant point. If I have an enlargement, so I have a triangle, I'm gonna do an enlargement and get a bigger triangle here. Right? And so find my center as usual. Find my center. I have to join the corresponding points like this. And go like this. That's my center of enlargement. That point also is an invariant point. Everything else in the diagram changed except that point. That also is an invariant point. So the center of rotation and the center of an enlargement are invariant points. Points on a mirror line are invariant points. Those are given. Points that move are invariant points. We can also calculate invariant points by calculation. It's only one time over CSEC give a question with that. If a point PXY is invariant under transformation M, then the point P is mapped onto itself by the transformation M. Right? So it means that object point and the image point is point under the transformation M. That is the calculation. That's what happens. The point PXY is mapped by a transformation M back to the same point PXY. Then that point is an invariant point. See there? That is what would happen. The matrix times XY will still be equal to XY. So if you ask you to calculate invariant point for a matrix, then basically you have to set this up. Set up this equation, solve it. Only one time I see CSEC do that over the years still. All right. So it's just time for us to do some questions now. All right. So I want us to do one or two questions before the day is out. All right. I want us to do one or two questions before we're out. So Sunday we're definitely gonna do that. We're definitely gonna do that that worksheet. So make sure everybody get them thing by Sunday. Get your sheets by Sunday that are sent in the group that we're gonna be using on Sunday. All right, make sure you get it. Very important. We're gonna be working those sheets on Sunday. Let me show you what I'm talking about. These, I'm gonna show you quickly. All right, you need to get this printed, guys. We're gonna be working through all these questions on Sunday. Don't do anything with them yet, you know. Wait on me, right? Don't go ahead of me with these questions. Wait on me. There are certain things I want to highlight for you with these questions. So don't do them yet. Don't do them yet until Sunday. I'll tell you when to do them.
Okay.
All right, that's what I'm saying. There's one on it that I want us to do today. All right, and maybe two that I want us to do today. But I'm not talking about the construction one, the calculation. Maybe this one down here. Might want us to tackle this one down here. All right. See if there's another one. This is a straight matrices, so don't worry about this. That's a straight matrices question. This one. That's a straight matrices question. I'm not talking about that. That's a transformation down here. Let me see. There's another one up here I want us to do. All right. Yeah, we're gonna do these on Sunday. Sunday and Sunday. Maybe some Sunday and some I'm taking my time and go through it carefully, make I get it, right? So this is document I need all to print out. Print them out. And don't do them until I tell you, okay? Don't do them until. All right. Let's do a short and then it'll get good. There's a reason I don't want you to do it until I tell you. I don't want to still emphasize certain things. I want us to do that last one. So I do have to do it on Sunday. But also, let me look. Also, there are questions on here that I want us to do. All right, so I want us to do at least one or two questions. So let me pick which one we're gonna do. Let me tell you which one we're gonna do. All right, let me see. I want us to do one. But the questions that are setting these days are much easier than these, you know. So you see if we can do these, believe me, it's gonna be a breeze. All right, so make sure you're trying to work all these questions. You don't have to force yourself. This is the same question that's on the page that I just showed you. This one over here. Same question. So we can actually just do it from right here. So let me choose one to start first. I'm going to choose one to start with something. So the question with the two parallel lines I spoke to you about. This is the question with two parallel lines, you know. So I said to reflect this. And eventually I'm not going to do it showing you. So the two parallel mirror lines there. So I'm going to reflect this over here. So first, sure. Alright, I have to reflect this over here so first and then reflect over this again. That's what the marks are first, right? Reflect it in the first one and get B. You reflect B in the second one and get C. So you create now, describe fully this geometrical transformation that would map A to C. So A, you know, A come to B as and then B go to C over as you know. Then I'm asking for the single matrix, take it from straight to A to C. That's a translation. It's gonna be a translation. And the translation is going to be twice the distance between the lines. Most distance is 1, 2, 3, 4, 5. So translation is going to be 10. 10 units to the right. And you can't say that translation without giving that. So I'm just showing you that. You can actually do it first. I just want us to do a calculation one now. Based on what we just did. So just give me a second. We'll pick the question that we're going to do right now. Before we move on, just give me a second. Saving through here to see which one I want us to do. All right. All right, see here. Let's do this one. Let's do that one. All right. All right, let's do this question, guys. This one. This one I'm going to do. All right. Let's do that one. I want us to do at least questions. All right. I want us to do at least two questions now. More maths equals better maths every time. All right. So we don't have to do this because that question is also on the page. So let's get right. Let's start putting all these knowledge together now. Show you all everything that I've taught you important. All right, I know the must know sheet important. Let's look at this question. That's a past paper question right there. All right, let's go. First part says write down a 2 by 2 matrix which represents R, a reflection in Y equals X. Simple. Y equals X reflection matrix. I'm just going to write it down. It is the one that looks like the identity matrix, but it's not. So it's 0, 1, 1, 0. Remember, the identity is this one, 1, 0, 0, 1. See, so quick me get my marks. Done. Get my marks so that I'm done. That's a X reflection matrix. Then I must call it R. Part 2. Part 2. Part 2. Write down the 2 by 2 matrix, which represents S, an anticlockwise rotation to 180 degrees about the origin. That's a 180 rotation matrix, as I told you. It don't matter if it's clockwise or anticlockwise, it's a matrix. You must call it S. Their form S equals the one that has the x-axis and the y-axis reflection in it. The y-axis reflection is minus 1, 1 here, 0, 0. X-axis is minus 1 down here, 1, 0, 0. Both the two minus ones them in it. So it's minus 1, minus 0. That's the matrix. Get your marks and you're done. Know the matrix, right? Don't get your marks. Next part of the question, please. Part 3. Part 3. I show you them questions are easy when you know your stuff. You know, I show you how it easy. Other students have to go calculate that out and work it out, you know. And calculate and work out that, you know. But you can just write it down if you know it, you know. So the question says write it down. Write it down. What that means? You don't have to do no calculation. Just write it down and get your marks. Next part. So you have to learn the most known items, guys. Next part. Describe in words. Tell them to describe in words this transformation. Only translation represented by that. It's a translation. Translation is the only transformation that is represented by this. And you have to say it's a translation. You have to say it's a translation. Let's write it down. Let's write it down like this now. Q equals 2, negative 1. See it here? Represents. Am I writing? Represents a translation. Give them a name of it. Translation. 2 units to the right. This means 2 units to the right. 2 units to the right. And what does this mean? 1 unit downwards because it's negative. 1 unit downwards. Do that to get the marks. You could have also said, instead of saying 2 units to the right and 1 unit down, you could have said 2 units in the x direction. And negative 1 unit. Negative means down, you know, in the y direction. Could have said that as well, right? That by example, get your marks. So what I wrote in purple, give you your marks. What I wrote in red, give you the marks the same. CXC will want to give you the marks, you know. So anything where you write to make sense or is truthful, they give you your marks. I don't show you how to express it. I would write this in my exam. And I know I get my marks. All right, but questions, when they set a question, they might use these terms in the x direction and in the y direction. That's why I showed you that as well. Because they would use these words in their questions. But if you write this, you get the marks just the same. Because you are saying the right thing. Right? If you go to the right, you're going in the positive x direction. If you go downwards, you're going in the up in the negative x direction. See? 3 parts of the question done. I didn't have to think, don't it? 3 parts of the question done, and we did not have to think because we know this and we know this. And we know what this means. when you don't have to think, you get through the questions quickly. You don't have to think when you know stuff. When you know stuff, you don't have to think. You just do it. Study, you must know. I study them. Look up here, so now, ready now. Bam. Determine the image. Determine the image of the point 35 under the following transformation. This one and this one. All right. Watch this now. Bam. So part 3, part 4. We're gonna call the point P334. Let's call it P. So I'm gonna say let P be the point 34, so we can reference it. All right. Just now, we're gonna do RS first. First thing we have to tell them, pay attention when you know about RS first. Pay attention. All right, for the RS first. Pay attention. Watch this now. Ready now. RS first. First thing, RS means, what does it mean? That's why I thought it means. I'm helping you now. What does it mean? What does RS mean? Somebody unmute the mic and tell me, what does S mean? Remember R is a matrix, R is a 2x2 transformation, you know, and S is a 2x2 transformation, you know. This one is a reflection in the line y equals x. That's a 180-degree rotation. You know, what does RS mean? What does it mean? Just did it a while ago. RS, what does it mean? All right. Answer. Next time I answer. It means RS means S followed by R. The second one there followed by the first one there. Because what does that mean is that they have applied R. So it means that R is the second one. R is the second one. They have applied the second one, first one. So RS means S followed by R. So what it means, therefore, is I can apply the S to the point P and then apply R after. But I can also multiply the R and the S and get it. I'm going to do it both ways and show you. First thing is to know that RS means that. Look at the mathematics big now. But let me tell you something now. I tell you all the question is easy. I know what this means before me even do the question. This RS followed by R is equivalent to a reflection in the line y equals minus x. I can tell you. So when I multiply these two matrices, I'm going to get a reflection in the line y equals minus x. I'm going to get, when I multiply them, I'm writing what I'm going to get to show you that I can know the answer even doing it before doing it. Watch this. I'm writing what I'm going to get. RS is going to be equal to a reflection in the line y equals minus x, which is 0, minus 1, minus 1, 0. When I multiply R times S, that's what I'm going to get. Let me tell you why now. Let me tell you why. I'm going to tell you why before I do the question. And I'm going to erase it down here. So what do we have? We have a reflection in the line y equals x. Right? That is the R matrix. That is the R, right? A reflection in line y equals x here. And we have a 180-degree rotation. So we have two transformations. We also have a 180-degree rotation. Now, if my rotation is 180 degrees, it means that my transformation is mirror line that is at 90 degrees to that one. So the angle between my two mirror lines is 90 degrees. That is why my rotation is 180 degrees. What does that mean? It means that two reflections go one rotation. See, you know, a reflection in this line and a reflection in that line is equivalent to a 180-degree rotation. Why? Because these two lines are perpendicular. I can put them in any order. In other words, I can have this first and then this, and it equals that. So I can put the three of them in any order. So I can have one reflection. I can have the 180-degree rotation. Then, because this is a vertical line, this must equal a line that is 90 degrees. This is 180 degrees, then these two be equal to another transformation, which is a reflection in a line that is perpendicular to this one, because these two must equal that one. I can also have the 180-degree rotation first, 180-degree rotation, and I also have a reflection in that line. These two will be equal to a reflection in that line. If I have 180-degree rotation first, and I have this horizontal line, so 180 degrees rotation followed by a reflection in a horizontal line, it's going to be equal to a reflection in a vertical line. Two reflections will always combine to give one rotation. And the three transformations can go in any order. So a reflection and a rotation give you a reflection. A rotation and a reflection give you a reflection. A rotation and a reflection give you a reflection. Two reflections go with one rotation. So look here now, how I know my answer. It's because what they gave me, let's look at it again. Because what they gave me was X reflection. They gave me that as one of my transformation. And they also gave me the second transformation, gave me is a 180 degrees rotation. Since rotation is 180 degrees, the angle between my two mirror lines, second mirror line, I know that these two equivalent to another reflection, you know. A reflection line must be at 90 degrees because the rotation has to be twice the angle between the lines. The line 90 degrees to the line y equals x is the line y equals minus x. So my answer, when I put these two purple transformations together, it must give me the y equal minus x reflection, which is minus 1, 0. That's why I say I know what the answer is. I even do anything. So I know that when I apply these two, I'm going to get that because of my must know items. All right, because of my must know item. But let me just work it out and show you. If you don't fully understand it now, don't worry yourself. You will get it as we go. And I'm showing you the power of the must know items. Two reflections give you one rotation. And so a rotation and reflection give you another reflection. Two reflections go with one rotation in any order. Because two reflections equal one rotation, then a reflection and a rotation equal a reflection. A rotation and reflection equal a reflection. A reflection and rotation equals a reflection. Right? That's how it goes. And the two lines must be at an angle half the rotation angle. Remember, the rotation is always twice the angle between lines. All right, so put this in a box. Let's put this in a box to show that it is supposed to be this. All right, I'm going to prove this to you. So this is not giving you the question enough. I'm just going to prove that this is what we're going to get when we multiply them. So I'm telling you that I know the answer before I even do it. Watch this now. Let's do the question now. So I'm going to work out what the answer is going to be. Easy. Watch this. RS means S followed by R. So I'm going to do the S first. I'm starting with the point P. Watch it now. Start with the point P, which is 3, 4. I'm going to apply S to it. Apply S to it. So S is a matrix. Minus 1, 0, 0, minus 1. And how do I apply S to it? I multiply it by the matrix 3, 4. And that's going to take me to my point. Let's call it P prime. Let's call it P prime. And we're going to work it out. So it's going to be minus 1 times 3, 0 times 4. So minus 1 times 3 is minus 3. So we're going to get minus 3 there. And then 0 times 3 and minus 1 times 4. I'm going to get minus 4. That's going to be negative 4. So my second value is negative 4. Negative 4. So I've done the S part. See? I've done the S part. Then I'm going to do the part now, the R part now. Let's do the R part right down here. Let's do the R part here. So now, bam, R. Let's do the R part here. So now, R. So I'm going to do the R right here. Let's just save some space. So the R is the matrix. What is the R again? 0, 1, 1, 0. And I'm applying that to now minus 3, minus 4. Applying that now. Applying that now to this point. Alright, so let's write this better. minus 3 minus 4. I'm doing S first, followed by R. So when I do that, what am I going to get? I'm going to get 0 times 0 times 3 is 0. I'm going to get times negative 4. That's what is going to be negative. If I can know it, when I reflect line y equals x, I can know certain things. When I reflect over line y equals x and the y value switch out, that go to y external. More things, the better. Work, the more things you know. I was supposed to learn that already from reflecting line y equals x. You interchange the domain and the range, so everything connected. So the answer for this really is minus 4 minus 3. All right, that's doing it in 2 steps. Or let's say I wanted to do it in 1 step. Let's use a different color and do it in 1 response. I'm going to do it in 1 step with the S. I'm going to use the S now to do 1 step. But first, I have to calculate the RS down here. Let's calculate the RS now. R is the minus the 0 1 1 0, and the S is the minus 0 0 minus 1. I'm telling you that the answer is this matrix, which is the y equals minus x reflection matrix. I'm telling you that's going to be the answer. Let's work it out and show you. I know my answer before I even did it because of my must know, because of my knowledge of the must know item. I know what the answer was before I did it. See there, look, 0 times 0, 0 times that is 0. This time this is 0. So the first value here is 0. See that? Then the value over here, so now watch it. 0 times 0 is 0. 1 times negative 1 is negative 1. Negative 1. The value down here, so now is this row times this column. So remember, I know, do that again, look, our master matrices application now, so I'm going to go through them something more, you know. Times negative 1 and 0 times 0. See, the value down here is negative 1, as I told you. And over here going to be 0. Watch this now. 1, 0, and 0 times negative 1. That is 0. So you see, I got the matrix that I wanted. Which matrix is this? This matrix is y equals minus x reflection matrix. I knew what the answer was before I did it because of my must know items. That's it. I knew that that's what I was going to get. So I'm going to apply this matrix to this point, and the answer is going to be this, just the same answer. So I'm going to apply the RS matrix now, the RS matrix, right? Which is 0, minus 1, minus 1, 0. Doing it in 1 step. Apply to the point 3, 4. Do the calculation and see if you actually get back that just the same. Look at it. 0 times this is 0, minus 1 times 4 is minus 4. See there, not telling you any lies. Next value for here, so is what? If 1 times 3 is negative 3, 0 times 4 is 0. See there? Negative 3. Same answer, doing it in 1 step. See that? So this is what I told you. RS means S followed by R. So when I do S first and then do R second, I get that. But I could do it in 1 step. So over here in the purple is 2 steps. Over here was 2 steps. Right? I use the RS matrix. When I multiply the R times the, I get the single matrix to get that. 1 step, I get the same answer. That's how the compound matrix work. All right, that's how the compound matrix work. I use the RS matrix. This is the RS matrix. This is the RS matrix that I use. Multiply by the point. But I understand that. I will stay. But I understand that. I know it's the first one we're doing. So if we're gonna get it fully, don't worry, save. As soon as we do some more, you'll see. All right. Let's do the SQ. Time for the SQ now. Next part of the SQ. Let's do the RS. Time for the SQ. So this is the answer. Everybody making noise. That's my answer for the RS. That's why I get under the RS, my answer. So this is like P double prime under the RS. P double prime under the RS. P double prime under the RS, right? That's my answer on the RS. Let's do the next part now with the SQ. Let's go SQ now. Everybody, and learn something from this one now. SQ. So now I'm gonna do SQ. SQ. We're going on the point P now. Let's go again. We're going on the point P. So we're gonna still go again and say let P. It's still 3, 4. And now we're gonna do RS. Now SQ. Now SQ means what? All right. And the most can tell me now. What does
Q
SQ?
followed by S.
Beautiful. So to get it quick, it means Q followed by S. So we're gonna learn. Lovely. That means doing it in 2 steps. And doing it in 2 steps. I put the Q first and then the S afterward. If I do the S first and then the Q afterwards, I'm gonna be wrong. SQ means Q followed by S. All right, so watch it now. Starting with the P, which is 3, 4. I'm gonna apply the S first, the Q first, sorry, the Q. Remember the Q is a translation, you know. So the translation one is the one that you add the matrix. So to the point P, which is 3, 4, add the Q matrix. That's how translation works. Q translation Q, remember, was 2, 1. See the only so? Q the only so was 2, 1 down here, so right? So yeah, 2, -1, 2, -1. So you add the translations, you're adding this to 2, -1. That's gonna take me to a point which I'm still gonna call P prime again. I'm using a different transformation. I'm still gonna call prime under this one now. It's gonna call me, that's gonna take me to 3 and 2 is 5. 4 minus 1 is 3. It's gonna take me to that point. Then if I apply S next, let's apply S right here. S, applying S now. Now S was the matrix again, -1, 0, -1. All this one does is negate the values, you know. Apply this to the 5, 3. But that's how I'm gonna get the 5. 3 plus 2 is 5. 4 minus 1 is 3. Right? Remember, this way for the calculation, but the point is actually written like this. Remember, that's how we do it, right? The point is actually written like that. You use a column vector for the calculation. When you write in the point, you write it like that. But for the calculation, you put it as column vector like that. You know, I will do that already. What's all this going to work out to now? It's going to give you now P double prime. P double prime. It's going to be what now? -5. -3 is going to be the answer. So here, -5 times 5 is -5. And then this -1 times 3 is -3. Right, that's because this is 0 times 5 going to be 0. And this 0 times 3 going to be 0. Right, so after a while, no, so just this time this. And this time this. All right, that's what we're gonna get. So that's doing it in 2 steps. So this is the answer, you know. This right here is the answer. This is the second answer. That's the answer. This is the answer for the SQ. Answer for SQ. Answer for the SQ transformation. And the answer for the RS. For the RS calculation. That's that. That's doing it in 2. Back to me now. Let's say I want to do it in 1 now. Let's say I want to do it in 1 step now. What am I gonna do now? 1 step using the SQ. What am I gonna do now? Talk to me. So I'm gonna do 1 step up here, so with the RS. Remember? The RS up there, so now. I'm considering doing it in 1 step down here, so now with the SQ. What can I do? SQ. Remember, S is a 2 by 2 and Q is a column, is a translation, you know. So remember, the Q is a translation and the S is a 2 by 2. Somebody unmute the mic and tell me what I'm going to do now to do the SQ. Up here, so when I have the R and the S, I just multiply the R times the S. See there? I multiply the R times the S down here, so that's what I did. And get the single matrix at RS is. RS is that single matrix. Apply that single RS matrix to the point and get and do one step down here. So one step that I did up there. Talk to me now. I do it in one step down here, so with the S and the Q now. Q is a translation. S is the rotation. Anybody unmute your mic and tell me what I must do. Come on, man. Unmute your mic and tell me. Up here, so no, so me up here, so I multiply the R and the S. I multiply the R and the S up here, so multiply the R and the S because I have two 2x2 transformation matrices and multiply them and get a single matrix. So in the exam, I can do it this way. I come around and do it in 2 steps, or I could do it this way and do it in one. 2 options to do it. I could do it this way and done, you know, or I could just do it this way and done. If not this way, I have to do that part I don't understand, multiply them out and get the one single matrix. So I'm saying down here now, suppose I want to do it this way in one single step. What would I have to do? Talk to me, man. Somebody unmute the mic and answer. No matter if you're right or you're wrong, just tell me what you think. Let me hear. Just tell me what you think. Let me see where your chain of thought going so I know how to correct it and fix it up. Nobody? Just tell me what you think now, anybody? If I call out somebody's name, just tell me the mic and tell me what you think.
You're going to times him.
Huh?
You're going to times him.
You're going to times them. All right. So that I don't want you to do now.
Then
right?
multiply the S by the Q.
All right. So this is a special case now. Remember, the rule, when we looked at the rule said 2 2x2 transformation, you can get a single matrix. In this one, it is involved a translation. So the 2x2, you only have 1 2x2. Rule applies to 2 2x2 transformation matrices. That's what the rule is. 2 2x2 transformation matrices. You can go back and find it and look at it. I don't want to come on for this. You know.
So, sir,
yeah?
why did you add in that?
Translation.
Why did you add that?
Because that's how you do translation. You add. It's the only one that you're adding the matrix. Other ones you multiply. The 2x2s you multiply. Translation you add.
All right.
You translate, you add. All right. But the
Yes, sir.
point of this now, is that this one we cannot do it in a single step. Why we can't do it in a single step? Because a translation is involved, which is a 2x2. You can only do a single step and get a single matrix when you have 2 2x2 matrices involved. Let me see if I can find it and show. Come on, you know. Well, let me see if I can find it. See, let me close this up. Jeez, we can find it back. See it, so. Yeah, that's it. All right, when 2 2x2. Watch this. Let me see if we can find it over here. So I don't want to close it now. See if we can find it and show now. Let's see if we can find it here. So you must know. Everything important, guys. See there, the compound transformation down there. So see there in bold letters. 2 2x2 transformation you must have for you to be able to multiply them and form a single matrix. See there, 2 of them to be 2x2. You say you can't do it when a translation is involved. See there? Note, a single matrix can be formed. No single matrix can be formed when a translation is involved. See it? So because that second one now involves a translation, we cannot form a single matrix. See? No single matrix can be formed when a translation is involved. And over here now in this example, we actually have a translation involved. We have a translation involved down here. Where is it? See there? Bam. Use a translation. See there? Cannot. Why? Because translation translation. Q is involved. You can only do it when you have two 2x2 transformations, like when we have up here. So we have a 2x2 transformation, we have another 2x2 transformation. So we could form a single transformation and do it in a single step. Right? We could do it up or down here now. You have to do it in a 2 steps. You can't one chart that can't do shortcut. You have to do the 2 steps. Once a translation is in. All right, I hope that stick. All right, no problem. I know it's the first time, but you're gonna get it. We're gonna do 1 million questions until you get it. Because more equals better maths. That's what they're asking us next now. What's your question, boss? Now? Yes, now. What is your question, boss? Now? Show them now, you know. Or CSEC must know. Show the power of the must know now. Power of the must know, we gone. Look question. What them do now? After we do ask if we do that, you know. See it now part 5. What them do now? Part 5. Part 5. CSEC question this, you know. Show the power of the must know now. Part 5. Describing words RS as a single transformation. See that? That's why I tell you have to know the answer before you do it. I tell you RS was. S has to be a reflection line, y equals minus x. Or multiply them to get the matrix. Y equals minus x reflection matrix, you know. So you have to know the matrices. But I could have known that that was the answer from up here. From up here. Why? Because I had a 180-degree rotation. And I also had a y equals x reflection. So because I have a y equals x reflection and a 180-degree rotation, I need another line that is 90 degrees. Because rotation angle must be twice the angle between the lines. So the line that is at 90 degrees to y equals x is the line y equals minus x. Y equals minus x. Y equals minus x. So this now is a y equals minus x reflection. That's the answer for that, you know. I knew the answer before I did it. Y equals x reflection. Right? So that's the beauty of it. So if you calculate it and get this, you still have to know which reflection, which that is. So that's why I tell you, you can know the answer before you do it here. And RS, which is equal to minus 1, 0 minus 1 minus 1, 0, represents a reflection in the line y equals minus x. That's what I want. A single matrix, single transformation. Describing her as a single RS as a single transformation. That's it. RS represents a reflection in line y equals minus x. Now, you know what student wouldn't know that if they don't know the must know say 2 reflection give 1 rotation. 2 reflection and 1 rotation go together. So if you have a reflection and a rotation, you must get another reflection. R is a reflection, you know. R is a rotation, you know. So a reflection and a rotation must give back another reflection. And the other reflection where you get must be at 90 degrees to the first reflection because the rotation angle is 180 degrees. If the rotation angle was 90 degrees, you know, then the other reflection would have been 45 degrees line, 45 degrees to the first line. You understand? Look at this question down here. This part down here. This part, so calculate the values of A and B such that point AB is invariant on the SQ. You want AB to be invariant on the SQ. What that mean? That means say you start at A and you end up back at A when you're done. That's what that means, you know? So let's look at part 4 now. Part 5. Part 6 that. Right? On the SQ. Now SQ is the second one, you know. You couldn't, but SQ is the one in 2 steps, you know. So it's like we start over. Start with the point A right? I'm going to apply the S first, the Q first. Remember, SQ means Q followed by S, right? So I'm going to do it says A, B, that's the point, plus 2, just 2, -1. That's going to take us to a point, A plus 2, B minus 1. We're going to apply the S next. Remember the S is, what was the S again? -1, 0, 0, -1. And applying that to the point A plus 2, B minus 1. You have to carry the letters because we don't have the values. When you apply this now, remember, you basically just multiplying these values by a -1 and multiplying these values by a -1. So it's going to go to the point minus A minus 2 and minus B plus 1. Oh, no. That's an invariant point, an invariant point. So if this is an invariant point, means that them 2 points are equal. And if them 2 points are equal, invariant point is invariant. Right? Invariant, So if invariant, if it's invariant, this will go equal the A plus E. And this will go equal the B plus equal to. Because an invariant point means therefore that my A minus 2 is equal to A. Right? Yes. This have got equal to this. Because an invariant point. Where you start and where you finish must be equal. That means that 2A have got equal to minus 2. So A have got equal to minus 1. Right? And secondly, this have got equal to B. Okay, so as an invariant point. So we have the finish point and the starting point have the same values. So the minus B plus 1 have got equal to the B. Okay, over the B again, you get 2B have got equal 1. If I buy that 2 there, the B have got to be equal to a half. And therefore, and the value of A and B, that's the answer. This is A, that's the answers. That's the answer. It's an answer for A, and that's an answer for B. So this question testing your knowledge of the invariant point. Point and the ending point have the same. After you carry through the transformation with the Q followed by the S, we end up with down here, most of it equal to the values where you start with. That's where you solve the equation. They have to equal because it's an invariant point. So the starting point and the ending point have to be equal. So we can write it like this. Here have to equal to point have to be equal to we'll start with AB. That's how we can set it that way there. So this have to equal A and this have to equal B. But if it's an invariant point, it means that the starting point and the ending point is the same point. So even though the calculation give us this, it means that this must be A. And though the calculation give us this, it must be B. Because the invariant point. Hope understands that. I want us to do one more question before we finish today. Because we're gonna practice on some more stuff. Just to run through one question. Here's the question that I said I wanted to show you. So somewhere up here. So I think where is it? Where did I see it? Right here. Right there. A very similar question to one that we do. This one, do it one as well, just to emphasize the compound transformation and that you can know your and stuff. All right, so let's run that question right here. Let's do that one. So it's very similar to the RS and the SQ that we just did a while ago. Very similar. All right, so this question said again, look at it. Write down the 2 by 2 matrix R for reflection in the y-axis. It's basically the same, almost the same thing, right? R is a reflection in the y-axis. A while ago did y equals x, now them the y-axis here, part 1. y-axis reflection. R equals -1, 0, 0, 1. That's the y-axis reflection mean. Y-axis, you have to know them. You see that in the question, you never know before. Get your marks and gone. Part 2. Write down the 2 by 2 matrix N, which represents a clockwise 180 degrees. A while ago, the question said anti-clockwise 180 degrees. No, say clockwise 180 degrees. Don't matter. It's the same matrix. 180 degrees rotation. Clock anti-clockwise is the same matrix. -1, 0, 0, -1. Why? Because of the y-axis reflection in it, it has the x-axis reflection in it. Both reflection in it. All right. That's it. That's the matrix N. Next one says, write down the 2 by 1 matrix T, which represents a translation -3 highlighted x-axis, 5 units to the y-axis. That's a translation. It's a translation. See it here? 3 units to the x and 5 units to the y. So simple. That's a translation. You're writing down. Exam easy, you know. E equals, then give it the values. -3, 5. That's a translation. Remember, once a translation is involved in any compound with them two here, you can't multiply them. You can't multiply them. You can multiply these two. You can only multiply these two, and form a single matrix. You can't involve that one in a multiplication and form a single matrix. Once it is involved, you have to do it 2 steps within a compound with a translation involved. All right, that's 3 parts done, you know. See similar question to what we just did a while ago, just to emphasize this compound transformation thing. So, you know, it says P is a point 611, call it P now, 611. It says, undergoes the following transformation, such as Rn on P maps P to P prime, while NT on P maps P to P. Let's write what those mean now. Let's write what they mean. Let's write what they mean. So we're doing part 4. We're going to do them one at a time. Let's do Rn and P. And I want us to determine the coordinates of P and P prime. So I must find the point P and find the point P.
Sorry, your mic is muted.
That's it. That I just got a call. All right, so let's go. All right, so already know. So we're going to Rn on P. Rn on P. So the first one, Rn on P. Rn P. So somebody tell me now what this one means. Rn on P means What does it mean? Rn on P. What does Rn mean?
Rn
followed by
means
P.
n followed by R, and
And followed by
It
R.
means N followed by R. So you apply the N to P first, and then you apply the R. It means N followed by R. That's what it means. N followed by R. Starting at the point, which is 611. We're gonna do N first on it. N is the matrix. -1, 0, 0, -1. That's a matrix. And that's the 180-degree rotation. I applying it to the point P, which is 611. That's gonna take it to a point, intermediate point. But the final point is P prime, The final point you're looking for, is P prime when you're done, So that's gonna take it to an intermediate point P, which we're gonna calculate. So it's gonna be the -1 times the 6, which is -6. And it's gonna be the -1 times the 11, which is -11. -11. And it's gonna get -11. And after we do that, now we have to apply the R now, the R next. So applying the R right here. So now it's to apply the R. So the R is again. The R is the in the y-axis right here. Y-axis is -1, 0, 0, 1. Apply that now to the -6, -11. That's going to take it to your P prime, your final destination, P prime. -1 times the -6 going to give you a 6. And then the 1 times the -11 going to give you a -11. -11. It's the answer, This is the answer. That's P prime done. That's the answer. Could we do it in a single step? Could we do it in a single step? Here. Could we do it in a single step? Using the Rn. Could we do it in a single step using the single matrix Rn? Could we? Could we do it in a single step?
Yes, sir.
Yes, sir.
2y2.
Yeah. Huh? Yes, because we have two matrices. So yes, we could do it in a single step. What single matrix are we supposed to get? I'm testing on us if you don't know yourself now. Watch this now. So we have the y-axis reflection. See if you don't know what the answer is supposed to be. I have a 180-degree rotation. So two reflections go with one rotation. Since rotation is 180 degrees, the angle between this line and the other line what I'm supposed to get. Them two here must equal what? A y-axis and a 180-degree rotation. Give me another reflection. What other reflection am I gonna get? What reflection am I supposed to get? The other line must be a reflection line. These two is equivalent to another reflection. Because two reflections go with one rotation. So I have a reflection and a rotation. The two of them must equivalent to another reflection. Two reflections equal one rotation when the lines are intersecting. So tell me now, what other line am I supposed to get? Which is the other line I'm supposed to get? Which is my other reflection line? When I multiply them two here, another reflection line. Which the single transformation, what's gonna be the single transformation? I don't know. Let me show you. The y reflection. Other line have to be 90 degrees to it, to the y-axis, because that's a 180-degree rotation. Rotation has to be twice the angle between the lines. So the rotation is 180 degrees, the angle between the lines must be 90 degrees. So the other line is at 90 degrees axis. Which line is at 90 degrees axis? The x-axis. So now multiply these two. I'm going to get the x-axis reflection. I can tell you, I'm going to get x-axis reflection, which is 1 negative down here, 0, 0. That's what I'm going to get. Understand? That's the beauty about it. You can know the answer of the must know items, guys. I know getting it, you know, really have it so fully yet. Right? Let me multiply them and show you down here. If I multiply r times n, the r is the -1, 0, 0, 1. And the n is the -1, 0, 0, 1. I'm telling you, the answer is going to be this matrix x-axis reflection. I must get. I know the answer before I even do it. Because I know that two reflections goes one rotation. The reflection, the rotation angle is twice the angle between the lines. So if one of the line of the y-axis, then the other line must be the x-axis. Because only the x that 90 degrees to the y-axis. That is it. Why I know it's 90 degrees? Because the rotation angle is 180. The angle between the two lines, the rotation is always twice the angle between the two lines. Look at your must-know sheet and you see it. Look at your must-know sheet and you see it. When I multiply these two, get it. Negative 1 times negative 1 is 1. 1 is 0. This is going to be 0. See it now? 1 times negative 1 is negative 1. 1. This is x-axis reflection. Has to be. So everything ties up. The calculation telling me and the must-know telling me. That's the x-axis reflection. So instead of going around, I could have just applied x-axis reflection to the point 6 and look at it. 1 times 6 is 6 here. Minus times 11 is minus 11 here. So I could have just used the fact that I know that it is x-axis reflection. Let me into and get the answer just the same. All right, don't worry, you're learning. So you watch the video and make them information and stick. Transformation easy because you know the answer before you do it. This is the Rn now I'm using as that. That's right here that I'm using. All right, I'm using Rn. All right, so I'm using this as my Rn. That's my Rn I'm using. Rn times the point. I know about this. Rn times the point. Rn is doing it in one. All right, let's go to the other one now. Other one now. Go back for the purple. One now I'm going to do down here. The second one now. NT on P. So I'm doing NT on P means. Talk to me now. What does this one mean?
T followed by N.
Beautiful. T followed by N. T followed by N. All right. So I'm going to put the T first and then the N. Important. Anybody who the N first, that's a dead. When I get it right. You have to know the NT means T followed by N. And you have to do T first. So starting at P. And T is a translation. Or you apply a translation, you add the matrix to the point. So start T. I'm going to do the transformation at first. Easy way to put it, P.611, and you add the translation to it. And the translation was to what? What was the translation? Negative 3.5. Negative 3.5 is the translation. T. See here? Negative 3.5. See there? Negative 3.5 is the translation. So adding translation. Now when you add that translation, take it to a point, intermediate point. 6 minus 3 is 3. 11, 5 is 16. 16, that's it. That's the first part. Second step, I'm now applying N. N is the 180 degree rotation. And I'm applying that to this point now, which is the 316. See that? And that goes negative 2 points. I'm going to go negative 3, negative 16. That's my answer. So here was my answer. I'm write it like this. This is my answer for Rn. Right? And this is now my answer for what is it? NT. T followed by N. All right, talk to me now. To do it in one step. Suppose I want to do it in one step instead now. Talk to me. Talk to me. I want to do the NT in one step.
You can do it.
And very good. Cannot. No. Cannot. Why? Why can't we do it in one step? Why can't we do it in one
Two by
step?
one.
Translation. See, a translation is involved. The only time you can do it in one step and get a single matrix is when you have two 2 by 2 matrices, as we did here, with a 2 by 2 and a 2 by 2. So we could multiply the second by the first one. See it? You multiply the R times the N. See it there? The second one, the R. See it? R times the first one, the N. See there? R times the N. Multiply the second one by the first one. Because Rn means that this is the first one, you know. All right, to get the single matrix, you multiply the second one by the first one. So you multiply them as they appear. You already know that Rn means n followed by 2. You can multiply them R times same way. So this one cannot because translation is involved. And if you want, you can try multiply them and get a single matrix and see if you get the right answer. You get the wrong answer, so that will prove it to yourself that you're gonna get the wrong answer. So if you want to multiply them and get a single matrix and see where you get, then you know. And another reason why it couldn't work, you know, suppose instead it was R. So since it is NT, we know so we can actually multiply a N by a T. Because that is possible. Right? But supposing that is NT, you can multiply them, but you're not, you know, don't do it. I'm not sure that it's something that can be multiplied. But suppose instead the transformation was Tn, meaning n followed by, you couldn't multiply the negative 3, 5 times the minus 1, 0, 0 minus 1, because you can't multiply matrices in that order. This would be a 2 by 1 and a 2 by 2. And because this have one column and this have 2 rows, you can't multiply. So you have to do something that can work in every case. But generally speaking, when translation is involved, you cannot form a single matrix. You cannot do it in one step. In case you have to do it in 2 steps. You know, no shortcut when a translation is involved. All right, guys. So I'm going to erase my thing. That's it. All right, how was there? How are we?
Sir, we put it, sir, but we still need a little more.
Alright.
Yeah, man, no problem. Work in progress. So that's why we have to do the activity on Sunday, right? We're gonna do the activity on Sunday to show it up some more. So we're gonna do the class activity on Sunday. That will help us to understand it even better. Because mastery we try to attain, you know, mastery. Mastery when you just see the question, you know what to do. Don't even have to. As you read a question, you just know what to do. And you can just write down things as I'm writing them down here. We have to follow everything I'm going to tell you. Study the most known item, that's where it starts. Study the most known items, guys. All right, and you'll be fine. Trust me, guys. So the most known items, and you see this question and say right through them and know everything you have to do. So the most known item must be your best friend Sunday. Genuine Sunday. Let's look at it now, quick, before we finish the class. Take another look at it. Where they best friend forever. Friend. The most known items. So let me hear everything we are talking about now. Right, I sent it all back in the group today. Right, the most known item and sent it out in the group today. So let me hear all these things. Make sure you know them. Everything. All right? Make sure you know them. So this showing it today. This one was the enlargement. Let's just one for distance. You can make a note on it for yourself too. Distance. When it comes to distance, is the length of image. I'm just gonna write length is equal to K and the length of object. Right? So this one is a known thing that's given. But this now is one of them like set question and that one. I'll write it better. You can see it, everything important. Of an image equals K alone times the length of an object. I can say distance, but this now, area of an image is equal to K squared times area of an object. And I like to set questions on that one. All right, so that's what we did today. Study all the matrices here, guys. ramp with it, guys. Right? Study them. Study them. See them there? Study them. Know them. That's a lot of matrices to learn, man. How much matrices is that? 5 or 8 matrices, man. And yeah, then matrix, we have just K0, 0, K. See there? And K is the scale factor, whatever the scale factor is. Man. You learn them matrices, the man. Know them. See the question them right. Write down this. See this there? Let me tell you, you must know them. See the question right there? Write down that. And write down that. Why am I tell you? Because I'm expecting you to know them. Know them. Know them. And so they ask me, describe a matrix. Describe, do a calculation and describe a matrix. Know what the matrix represents. You know how to describe what it is. Sometimes they give you the matrix and they can give you this matrix, you know. You can give a matrix, for example, you know, and they ask you, describe the transformation represented by that matrix. So you have to know so that the matrix for this. Reflection to the origin, I want it to give you rotation. You have to know if you tell them. So sometimes they give the matrix and ask, describe it. I'm sure no one think I like me. Meaning it's a shy, no. Oh no. Sure, I think I like it. Sure, no, fine on and show for the class. See them give them matrix there. Answer the single matrix. Hold on. All right, see it now. D. Describe fully the single championship map under that. I'm not sure no. Sure. And give the matrix and then ask you to describe it. I'm not sure. I think I line. All this thing. Where is it? Aha. You see? All right. So one here. I think I line me and tell. So one there. See there? Question, give it a matrix, describe geometrically transformation represented by it. So then give the matrix and I want to tell them what it is. And give the matrix and what it is. This is an enlargement of scale factor 2 about the origin. This is a clockwise 90-degree rotation matrix about the origin. So you have to know the matrix is just the same. So it's me telling them can give a matrix and ask what they are to. And every time them are just see the up this question, you know. They ask if you write down some matrix, you know. They ask go to question wicked, you know. They ask if you write down the 2 matrices for the y-axis reflection and for the 180-degree rotation. So if you know them 2 matrices there. And then down here, so now. And they say, watch out now. Them say must determine the single matrix U which represent MY followed by RL. That's the x-axis reflection, you know. Someone know the answer. That's the answer, you know. That's the answer, you know. Why? Because I have a y-axis reflection, I have a 180-degree rotation. So the other line must be at 90 degrees to the y-axis, which is the x-axis. So the answer is the x-axis reflection matrix. That's it. The answer for this, we know the answer for this already without even doing it. The answer is the x-axis reflection. See? I said in the matrix. So I know so when I'm out them, I go and get the x-axis reflection. I know the answer already. Right? And then answer now and give them to them. And say you must describe them. Telling you. For the shots and no joke thing. Another question here, something like me, I tell you right and right. See there? Q are 2 transformation. This one and this one. This one is a y equal minus x reflection. Y equal minus x reflection. And that one at the x-axis. So the x-axis reflection. So then give y equal minus x and then give x-axis. Them 2 they give one rotate 180 degree, you know. How me know? So you have y equal minus x also. No, 90 degree here. I have x also. Right? So the angle between them 2 lines are 45 degrees. So the 2 of them equivalent to a 90-degree rotation. See? I'm asking for the single matrix. Asking for the single matrix. It's going to be a 90-degree rotation single matrix. 90 degrees. I know the answer already. It's going to be a 90-degree rotation matrix. Just have a look and see which one comes first to get the direction. Right? To get the direction, it depends on which one comes first. So it's either clockwise 90 degrees or anti-clockwise 90 degrees. But see the question, I give the 2 matrices them, and then after them, you go and describe them if you don't know them. Yeah, so this one is a reflection in line y equals minus x. And this one is a reflection in the x-axis, that one. I need to do the single matrix now. R followed by Q. You multiply the Q times the R. See the R followed by Q, QR. So multiply the Q1 in front of the R1. Which one are the Q1? Oh, the first one of the Q1. This is the Q1. And this is the R1. Right? So then put another nice order for you. R by Q is Q times R. So multiply this one in front of this Q times R. And you'll get the rotation matrix. And I get the one with -1 down here and here. You're going to get the one down here. So -1 up here. So 0, 0. You're going to get the 90-degree rotation matrix. Depending on which one comes first, I could tell you which one comes first. All right? This I could tell you which one comes first. But I know you're getting the rotation. Answer before you even do it. So you see, I'm not telling you any lies that I'm preparing you to crush these questions. Crush them. Know the answer before you even do it. That's what I'm preparing for. For that, I'm telling you. Study them something. Kill it. See it? It's a glide reflection there, you know. So everything I must study, you know, about that foolishness, you know. Everything I must study, you know. Everything important. I sent it to you today, separate. I cut it off and send it to you today in the group. So I say everything, study everything. Right? This is a -1. This is m to the -1 right here. So this right here says m to the -1. M to the -1. That's what that is. That's m to the -1, I think. And right here so too. It's m to the -1. All right, just like how this is m to the -1, right? Cool. Cooly. All right. But good, honestly. Think soft, you know. Do what I'm telling you for doing it so I'm get soft. Like porridge. Soft with a capital T. That's how we're gonna make the maths. We have to do the things to make them soft. All right, I end it there now. No. Let's end it for today, guys. We'll pick it up back on Sunday and have a lot of fun with these things because they are very easy. All right, everybody, good? But all right.
Yes, sir.
Yes, sir.
All right. Remember what video? Watch over the video. Do the example. Do the same example I did today. Do those first. Same question that today. Do those questions first, and you can start trying them. I don't care if you get them right or wrong. Activity on Sunday that will help you to master it even more. All right. See you all on Sunday, guys. I'm gonna end it now. Bye.
All right. Thanks for the
Bye,
class.
sir.
All right. Cool. All right. Bye, Princess Sky. Bye, my princess. Bye.
Bye.
All righty.